In this video, I want to show you how we can use the graphing calculator with a matrix equation to be able to solve a system of equations. So, example, use a matrix equation with the graphing calculator to solve each system of equations if possible. So, if we have this system of equations in part A, then we'll begin by writing this as a matrix equation. So as a matrix equation, we'll write our coefficient matrix, which will be -2, 3, -3, 4. So that is our coefficient matrix, times our variable matrix, x, y, and that will equal our constant matrix, 4, 5. So this is our matrix equation. So if this is the case, then x, y will equal the inverse of the coefficient matrix times the constant matrix. So what I'm going to do is I'm going to use my calculator to enter the coefficient matrix and the constant matrix, and then I will do the multiplication of the inverse of the coefficient matrix times the constant matrix on my calculator. So if I bring in my calculator, I'm going to go to second and matrix, and I'm going to enter my coefficient matrix into matrix A. So that is a 2 by 2 matrix in this case, and the entries are -2, 3, -3, 4. So I've entered my coefficient matrix, the matrix that I'm going to find the inverse of, into my calculator. Now I'm also going to enter in matrix B. So edit matrix B. Matrix B is a 2 by 1 matrix, and its entries are 4 and 5. So I have matrix B in my calculator. Again, that's the coefficient matrix. Second quit to get back to the home screen. So I'm going to do matrix A, and I'm going to find the inverse of that times matrix B. So again, this is the inverse of the coefficient matrix, that's this, times the constant matrix, that's this. And so that gives me the result 1, 2. So that tells me that x equals 1 and y equals 2. So this tells me x equals 1, y equals 2. So the solution to this system is the point 1, 2. Now I can do the same kind of thing for more challenging systems of equations like here in part B. So the same kind of deal. In this case we have a system with 3 equations and 3 variables. So I'm going to start by writing my coefficient matrix, which in this case will be a 3 by 3 matrix. We have -3, 4, 2, 2, 3, 1, 5, -6, -3. So this is my coefficient matrix for this system. Times the variable matrix. The variable matrix is going to be x, y, z. And that's going to equal my constant matrix, which is going to be 2, -1, 4. So x, y, z is going to equal the inverse of my coefficient matrix, so that's going to be the inverse of this coefficient matrix times the constant matrix. So I need to enter my coefficient matrix in the calculator and my constant matrix in the calculator, and then do the inverse of the coefficient matrix times the constant matrix to get the answer. So if I bring my calculator back in, I'm going to matrix. I'm going to edit matrix A. This time matrix A is a 3 by 3 matrix, and the entries -3, 4, 2, 2, 3, 1, 5, -6, -3. So I have my coefficient matrix entered into the calculator. Back to matrix. This time I'm going to edit matrix B. This time matrix B is a 3 by 1 matrix with entries 2, -1, and 4. So I have my coefficient matrix entered into the calculator. Second quit to get back to the home screen. So I'm going to do matrix A inverse times matrix B. And I've typed times here, but you really wouldn't have to. The multiplication would be understood. So if I did not put the times symbol there, it would work just fine. And so I get the result 14, -51, 124. So this is equal to the 3 by 1 matrix, 14, -51, 124. So that tells me that x equals 14, y equals -51, and z equals 124. So in other words, the solution is the ordered triplet, 14, -51, 124. So this is how we can use a matrix equation with our calculator to quickly find the solution to a system of equations.